Okay, so in this video, what I want to take a look at is going to be object serialization. In order to fully demonstrate some of the concepts surrounding object serialization, I want to go ahead and bring in two files from a previous project. So these are actually going to be two files related to a program in which we discussed aggregation with classes. This is from back in Chapter 8 of the materials for this course. So we're going to use the president class and the company class. We're going to go ahead and add these to a new project. So if you're doing this from a text editor, you're just going to go ahead and make sure you have those two Java files along with a third file that we'll create in a moment. If you're doing this as a project in NetBeans, you're going to end up creating that project and adding these two files to the package, the package for that project. So the name that we want to go ahead and use, go ahead and create a new program or a new project. And for this one, this is going to be demonstrating object serialization. So I'm going to call this my serialization demo. Okay, so go ahead and save that. And we'll go ahead and make our class header. So this will be our serialization demo. Inside of here, we're going to go ahead and include our main method. So we'll have our public static void main, and we'll have our string array of arguments. Okay. So the way that we want to go about doing this is going to be very similar to what we saw when we were dealing with binary files. So the types of classes that we're going to need will again be things that come from our IO package. So we're going to do import java.io.star. So I'll use that wildcard import to go ahead and grab everything from there. In this serialization demo, the classes that we're going to be interested in, so if you recall, when we were dealing with our binary files, we were working with things like our file output or file input streams, as well as our data output or data input streams. So we had those four classes to work with. In this particular case, the one difference is going to be that now we're going to be working with object output and object input streams instead of the data output or the data input streams. So in this case, when we deal with object output streams, that's going to be when we take our objects and we write them to the file. So that's going to be the serialization process. And when we deal with our object input streams, that's going to be when we want to take the serialized object in our binary file and we want to be able to read that back out or deserialize it. So in this case, we're going to be doing this first with president. So I want to demonstrate it by using just the president class, and then I want to expand on this a little bit more by using the company class as well, because of the fact that we have this field that's using a president inside of it. So coming over here, we have our initial code for our president, and what I want to be able to do is add a little bit more to this so that it's actually ready to go for object serialization. And what I need to go ahead and include with this is actually going to be another class that comes from the IO package. And I need to go ahead and import it into this file as well. And this one is going to be this serializable class, or more precisely, this serializable interface. So because this is an interface, we're going to go ahead and use the implements keyword, and we want to say that president implements serializable. Okay, so now by doing this, now we can say that president is a serializable class, meaning that now we can actually use it for object serialization, meaning that essentially we're going to take the data in our Java program for the objects of this class, and we're going to be able to convert those to the appropriate raw binary format so that we can store them into a binary file. So then coming over here, we will go ahead and just set up a couple of different classes. For this particular example, this will be the one instance where I'm going to kind of cheat a little bit. We'll just rely on a throws clause to accomplish this. And we're just going to go ahead and use that instead of trying to do this with try with resources, so that I can very quickly just briefly show you the four different classes and the relationship between them. So the first two that we're going to need, we're going to have our file output stream. So for this one, again, we can use things like fstream. Since I'm going to go ahead and do this with both file output and file input, I'll kind of keep them distinct. We'll say file, our file output stream we'll call outstream. This will be equal to a new file output stream. We then want to go ahead and specify the name of the class we're going to write this to. So ultimately, I'm going to be using this with both president and company. So I'm just going to call this my company.dat file. Okay. We will then also go ahead and have our object output stream. So this is going to be what actually sets up the connection for being able to write an object to our file. So for this one, this will be our output file, or I guess more precisely we could say object output file. This will be equal to a new object output stream, and this is going to be taking that file output stream that we just made. So we'll have outstream right there. Once we've got that set up, then we can go ahead and create our president object. So to do that, we'll call the constructor for it. In this case, we're going to be doing the parameterized constructor, so just passing in a string for a name. So go ahead and make our president object. We'll call this just pres. This is equal to a new president object. And this time around, I will actually have the correct name for the president of Microsoft. So the current president is going to be Brad Smith. We'll go ahead and use that as our president for this, this demo. And then once we've got that, we can go ahead and access our object output file. Go ahead and have this separated. And we can go ahead and do another write method. This time around, we're going to do write object. So this is what we're going to use to actually write an object to our file. So we'll put in pres right there. And then once we're done with this, we want to go ahead and close it. So we'll take our object output file and close that. Okay. So we'll go ahead and save this, we'll go ahead and run it, and then we'll take a look inside of our newly created company.dat file to see this, this president object that we're currently writing to it. Okay. So coming over here, go ahead and do a compilation. We're going to need to compile president, company, and serialization demo, since these are going to be all of the files that we're working with. Okay, we'll then go ahead and run the serialization demo. Okay, so we're able to successfully run that. So we'll come over here. We'll go ahead and locate our company.dat file. We'll go ahead and find that in your project if you're running it from an IDE. We'll go ahead and open this. And inside of here, we've got a little bit of data for this right now. You'll notice pretty quickly that the amount of data we put in here is a fair bit larger than, say, for our strings or our sequences of characters from our previous examples. You know, if we use something like, say, message.dat as an example, we've got just the phrase hello earth. Maybe if you look at this binary.dat here, this is the amount of data when we have 3 different strings put together. And compare that against our company.dat, where we have a single president object that takes up almost just as much space. So it kind of gives you a general idea about the size of our objects. And it's also worth noting that if we look at the president, you know, the only piece of data that the president objects need to hold is just a string for the name. In this case, you know, the string for our name is only 10 characters, counting that space, and it still ends up taking up about 5 lines of binary data. So it's worth noting that, you know, relative to other, say, like all of our primitive data types, our objects do tend to be fairly large. You know, which helps to explain why it is that objects are handled the way that they are in both Java and other programming languages, you know, more precisely object-oriented programming languages. So in addition to being able to write this to the file, we can also read it from the file. So let's say that after we've gone through this whole process and we've closed our object output file, we want to go ahead and make another connection. So we'll have object input file to read from it. So for this one, we'll go ahead and do our file input stream. I'll go ahead and do these separately just to show each one of these individual classes. And for this one, we're going to do a new file input stream. And we again will be connecting with company.dat. We can then go ahead and do our object input stream. This will be our object input file. This is equal to a new object input stream, and we'll put in our in stream right here. We then want to go ahead and get back this president object that we had put into it. So in order to do this, we want to go ahead and declare a reference variable. So for this one, we're going to say, let's go with just something simple like new pres. And this is going to be equal to the object that we are reading from the file. So we'll go ahead and include that much. We've got our object input file dot read object. But an additional thing that we need to include as well is we also need to do a typecast to make sure that we are properly converting this from just sort of, you can think of it as being sort of just like a general or generic object that we're trying to read from it. We want to make sure that Java is able to correctly interpret that as a president object. So we do a typecast right here. Go ahead and set that up. And then if we wanted to, we could go ahead and access that president object. So we have a new pres right here. Keep in mind that we have a toString method that we can use. So if we wanted to at the very end, we can go ahead and do a system.out.println, and we can actually just pass in new pres right there. And then we can also go ahead and close our input file. Okay. So then if we come back over here and we compile and run this, we should also make sure that we have one additional exception that's included here. So in addition to being able to throw an IO exception, we can also go ahead and just add on to this. So we can include this class not found exception. We'll go ahead and save that. We'll come back over here. One thing to note is for class not found exception, unlike IO exception, which comes from the IO package, class not found exception is going to come from the lang package, so I don't need to do any kind of import for that particular one. Go ahead and clear this and try it again. Now we can go ahead and compile that. So one thing to note is I kind of did this very quickly, but the general syntax when you need to specify different kinds of exceptions for a throws clause, you don't generally see this, since typically you're setting it up in such a way that either you only need a single type of exception in your throws clause, or in the vast majority of cases, people just don't really use throws clauses as often as just using try-catch blocks. But if you want to be able to catch multiple types of exceptions with a throws clause like this, it's just going to be a comma-separated list, kind of like what I did right here. Okay, so now that we've got that covered, so we are able to successfully compile it, and then we'll go ahead and run it. And so then when we run it, we can go ahead and put our data into this file, and then we'll go ahead and read from it, and we'll print this out to the console, and we can see that we are able to successfully take the object that was in that binary file. We can deserialize it so that we can convert it back to an object in Java code, and then be able to actually access it for this print statement. So we go and print out the name of the president is Brad Smith. Okay. So this covers everything when it comes to using a class like president, where the only type of data that we're dealing with is either, say, one of these classes that comes from the Java API, or some kind of primitive data. But what if we're dealing with something like the company class, where we've also got our president? Well, to start off with, we know that we need to do an import. So we know that we're going to need to get that serializable interface from our IO package. We know that company needs to implement serializable. So we need something kind of like this. So then if we come over to our serialization demo, say maybe instead of trying to do this with our president, maybe instead now I want to go ahead and replace every instance of this with making a company object. So we're going to do a company, we'll call it comp. Instead, for this one, we're going to go ahead and give it that president, but we also need to give it a name. So for this one, we're going to go ahead and say, for the name as a string, we're going to give it Microsoft. And then for our president object, we need to make a new president right here. So we're going to go ahead and make this little modification to our constructor. We're going to go ahead and write this company object to our binary file. We can then come down here, and for this one, we're going to be doing it with a company. We'll call this new comp instead now. And when we do our typecast, instead this is going to be company. We've got a couple of others up here to deal with. So we have a new company, Microsoft, new president. We have our company, the typecast, and then right here we want to go ahead and do this. Okay. So the way that we got this set up right now, we know that our company implements serializable. We're using president as one of the fields, and if you look in president, that's also going to implement serializable. So if we go ahead and compile and run this just as it is, go ahead and clear this, go ahead and compile everything, and then we go ahead and run it. We can, at the very end of this, get the name of the company is Microsoft, the name of the president is Brad Smith. So when we compile and run it, we see that there are no issues with the way that this is set up. So the reason for that is because of the fact that everything that we're dealing with, both company and president, is implementing the serializable interface. But what if we've set it up so that company can be serialized, but we've neglected to set it up so that the president field can also be serialized? So say maybe we remove this right here. Okay, and this becomes a pretty big concern if we're dealing with an aggregate class. So say like company being the aggregate class here, where the aggregation deals with several other classes. So maybe you've got something like 5 or 6 other classes, and you don't necessarily want to make it so that every one of these other classes also implements serializable. Maybe for some reason you've decided that some of them shouldn't do that. So if we try to compile this, just to take a look at what's going to happen right now. So everything will compile, and then we'll run it, and we'll get this exception right here where it'll say not serializable exception, and it's warning us about the president class. So we need a way to be able to work around that if we choose that we don't want president to be serializable, but we still need to be able to run this program anyway. And what we can do is there's actually another keyword that we can include with this, which is the transient keyword. And the way that this is going to work is that it will actually allow us to essentially ignore or disregard this president field when we go through the process of serializing our company objects. So if we take a look over at our company object right now, this is all of the code for it. So we can see that there's 73 lines of it. Whenever we're dealing with aggregate classes, the combination of having both the aggregate class and then the inner object for that aggregate class, it ends up taking up a lot of space. So let's see if there's any effect that the incorporation of the transient class or that transient keyword will have on the amount of data that's being stored in our binary file. So we'll go ahead and compile this again. We'll go ahead and run it again. So we're able to run it. We do run into a little bit of a problem right here. So we need to address that, or at least say something about that. If we come over here, we also can see though that the amount of data that's being stored in our binary file is a lot shorter. So the reason that this data is a lot shorter is because of the fact that when I said that we were going to ignore or disregard that in the serialization process, I meant that in the most literal way possible, which is that when we go to convert all of our code for this object into a raw binary stream to store into that binary file, when it sees all of the code for the president object, it's going to completely ignore or completely disregard that, and it's not even going to try to transition that over to the binary file in any way. So because of that, when we actually read that object back from the file, it again still isn't going to have that part for the president anymore. So it's going to completely lose that data in this process because we chose to use this transient keyword. So generally speaking, if you're going to do it this way, you want to be absolutely certain that you're doing it in a situation where it's perfectly fine to essentially lose this data. Admittedly, I can't really think of any practical situations where you would necessarily want to do this, but there could be situations where that might come up. One last thing that I want to mention about this transient keyword, you might have already noticed that there is something kind of interesting about string, which is that string is another class. So these are objects of a class whenever we create one of these string literals, but we've never had to use the transient keyword whenever we want to store any of our strings as binary data. So they don't really seem to they don't require this, and the reason for that is because of the fact that there are certain classes in our Java API, string is one of them, that already implement the serializable interface. So this is actually already done for us, which is why it is that we didn't really have to worry too much about that, both in this example and also in some of the previous examples where I've been showing the use of methods like write UTF or read UTF. Again, because of the fact that that's dealing with strings, that is actually technically another example of object serialization and object deserialization. We were just able to kind of ignore the fact that that's what was going on there because of the fact that the Java language is already set up to do that for us, essentially. Okay. So at this point, this is going to wrap up everything related to Chapter 11, covering everything for exceptions and advanced file I/O. So this will conclude all of the stuff regarding handling exceptions with try catch and finally blocks, or try with resources blocks, with being able to throw our own custom exceptions using throw statements. And then as far as advanced file I/O goes, covering everything for binary files, random access files, and this most recent topic for object serialization and deserialization.